Vlak bij de Universiteit van Pavia staat het gebouw van het Eucentre, het Europees Centrum voor Training en Onderzoek op het gebied van aardbevingstechniek. Er wordt onderzocht hoe gebouwen reageren op een aardbeving. De NAM heeft hier de afgelopen jaren 7 complete huizen laten testen. Die testen gebeurden op een schudtafel. Het Eucentre heeft er 2. De grootste schudt het huis van links naar rechts en weer terug. Op deze schudtafel zijn de 7 complete Groningse huizen getest. Het Eucentre heeft in 2019 een tweede, kleinere schudtafel in gebruik genomen, die een aardbeving nog beter kan simuleren.
The special thing about it is that it can move a structure on top of it in 6 degrees of freedom. So you can have a shaking in one direction, horizontal, another direction, horizontal, the vertical direction, but also rotation on all 3 angles. So that's what is very special about this shake table.
Deze schudtafel is ongeveer half zo groot als de andere. Die heeft veel meer power en dat heeft een reden.
The other one that we have here is much larger, is roughly the double the size. It's much more powerful. You can introduce accelerations and you can construct specimens that are much larger, but you can only test those specimens in one direction, because when you have a lot of power, it's very difficult to control more than one direction. So when you have more directions, then you have to scale down the size of the specimens. So in a sense, the 2 tables are complementary.
Er komt heel veel bij kijken om zo'n schudtafel goed te laten functioneren. De tafel wordt op zijn plaats gehouden door dikke betonnen muren.
This is the mass of concrete. It's 5 meters tall. It's a highly compressed concrete. You can see here the heads of the post-tension cables that are making sure this concrete is very compressed. And so the shake table, the actuators are pushing against this concrete, and this concrete does not move, because what should be moving is the table, not the support of the actuator. The other interesting thing about this massive piece of concrete is the fact that it's resting on seismic isolators. So you have quite a few of seismic isolators underneath this. The reason for that is that when the actuators are pushing against this mass in order to shake the table, they are transmitting vibrations to the mass, to the concrete mass. And we do not want those vibrations to go to the ground and then to be transmitted to the buildings surrounding the lab.
Om deze kleinere tafel ook op piekmomenten voldoende kracht te laten genereren, zijn er zogenoemde accumulatoren nodig.
So these are accumulators, and the reason why we need them is because the hydraulic pump that moves the actuators, that moves the table, is able only to supply up to 80% of the maximum capacity, of the maximum acceleration. For that extra 20%, what we do is that we have hydrogen under high pressure and we release it, and this gives you that extra 20% of acceleration that you need to reach the peak values.
Begin 2020 heeft de NAM een aantal tests laten uitvoeren op deze nieuwe 3D-schudtafel. Dat gebeurde met verschillende losse onderdelen van een huis.
We wanted to test a structure that is a sum of different components, structural and non-structural, in order to study the behavior, the seismic behavior of these different components. For example, we have 2 different chimneys with 2 different slenderness, so one is shorter than the other. We have a gable that is completely unrestrained, so the most vulnerable that we can imagine, because it's simply standing there alone. And then we have 3 different parapets, plus all the structure that is sustaining all these components. Yeah.
De elementen die losstaan van de constructie kunnen tijdens een aardbeving naar beneden vallen en zo een gevaar vormen voor de omgeving. Een test met deze elementen, die ook wel hoog risico gebouwelementen worden genoemd, geeft nieuwe inzichten in hun gedrag bij aardbevingen.
We had the possibility to build 3 identical or theoretically identical models, and we test them. We are testing them in 3 different conditions. This is the first time that this is done in general, not only here in Pavia. So we tested the first one under a monodirectional load, so acceleration, horizontal. The second specimen that we tested in December was tested in a bidirectional condition, so horizontal and vertical in the same time. And what we are testing now, is a directional. So we have the two horizontal acceleration plus the vertical.
Bij deze test wordt de aardbeving van Zeerijp in 2018 nagebootst. Die beving van 3,4 op de schaal van Richter veroorzaakte de grootste piekgrondversnelling die tot nu toe in Groningen is gemeten.
For this specific test, it is a 3D component, so it's exactly what was recorded in the 3 direction in the field. For example, this one has a PGA, so horizontal peak ground acceleration, so maximum acceleration of around 0.1 g, and a vertical acceleration of around 0.07, so 0.7 meter per square second, that are approximately synchronized. So basically the input will be the peak of the acceleration in the 3 direction are approximately in the same moment.
Ook al bewegen de losse, niet-constructieve gebouwelementen door de aardbeving, ze vallen niet naar beneden. Wel is er lichte schade aan het gebouw die nauwkeurig wordt vastgelegd. De onderzoekers in Italië hebben na deze test nog een aantal zwaardere tests uitgevoerd, waarbij de kracht van de aardbeving langzaam groter wordt. Na elke aardbevingstest wordt het gebouw nauwkeurig geïnspecteerd en wordt de schade aan het gebouw opgenomen.
We select an earthquake from the Italian sequence of 2016, not because we are in Italy, but because these actually had we found this record because it's very synchronized. So basically the vertical component is exactly at the same moment as the horizontal component. We are thinking that this is the worst case scenario considering the vertical acceleration.
De eerste test in één richting wordt gedaan op de grote schudtafel. De kracht van deze aardbeving is 1,5 keer zo groot als gemeten tijdens de tektonische aardbeving in Italië. Bij deze test komen grondversnellingen vrij die wetenschappers niet voor mogelijk houden in Groningen. Duidelijk is te zien dat er een borstwering losschudt en valt. Wanneer de constructie wordt geschud met 2 keer de versnelling van de Italiaanse tektonische aardbeving, beweegt de schoorsteen heen en weer. Bij een volgende test op de kleinere 3D-schudtafel wordt het gebouw in 2 richtingen geschud, horizontaal en verticaal. En bij deze test wordt de constructie in alle 3 de richtingen geschud. De onderzoeken in Italië zijn inmiddels afgerond. Ze vonden plaats onder leiding van professor Rui Pinho van de Universiteit van Pavia. Hij legt uit wat het doel was van dit onderzoeksprogramma op de 3D-schudtafel.
Well, the goal was actually twofold. There was a primary goal, which was to assess the impact of vertical ground motion on the response of the type of masonry buildings that we find in the Groningen region. So that was the main goal. And the second goal was to assess the impact of applying 2 simultaneous horizontal components of ground motions to those masonry buildings. The previous set of tests that were carried out within this research endeavor considered only one direction of ground motion. We wanted to be completely sure that the results obtained with only one component of the ground motion were still valid. And so we wanted to do these tests considering both components of horizontal ground motion as well as the vertical one to see if the results would change or not when these other components were considered. Well, we've got a confirmation that for this type of masonry structures, the type of masonry structures we find in the Groningen region, the vertical component of the ground motion has a relatively minor influence in the seismic capacity of the structure or in the seismic capacity of its structural and non-structural elements. So that was one of the main findings. findings. The other finding was that, again, a confirmation that assessing these structures for two horizontal ground motions separately leads to the same or very similar results of that you get when you assess the two components simultaneously. So there is not really a need to consider them simultaneously. Considering them separately, as is standard practice, is quite all right. These results are very important because there was a very extensive experimental test program that was carried out, not just in Pavia at the Eucentre, but also in other laboratories, such as the LNEC in Lisbon, Portugal, as well as TU Delft. And in those tests, only one component was typically used, and the conclusions on the capacities of these masonry structures were withdrawn from those one direction tests. And thanks to this last set of tests that we've carried out here at Eucentre, we've managed to confirm that all those findings, all those results obtained from those tests in TU Delft, in Pavia, in LNEC, were perfectly valid. Well, as usual, these type of results, they are used to, one, calibrate numerical models so that we can model structures, or in this case, model the types of structures that you find in the Groningen region, model them and assess their response when subjected to earthquake action. So that's one of the main uses. The other one is to calibrate the design code, the seismic design code. So the results that we've obtained experimentally can be used to define better the equations that give you the capacity that structures must meet when they are designed in the Groningen region. These types of masonry structures that we find in the Groningen region, we find them as well in many other areas of the world. And indeed, the results that we've obtained have already been requested. The test results have already been requested and downloaded by researchers all over the world interested in these types of results, because those structures are present also in their countries of origin. And the other thing that I should note is that the seismic input that was used in this test was composed of, on one hand, an earthquake recording from the Groningen field, but also an earthquake recording from a tectonic earthquake, from a strong Italian tectonic earthquake, so that again, we could obtain results that are valid both within the induced seismicity scenario of Groningen, but also valid for tectonic earthquake scenarios that you find elsewhere in the world. So two things. The first one is that we have produced and submitted for review and publication in international journals the results of the tests. And so these results, these findings, the way the tests were carried out and the results that were obtained were subjected to the scrutiny of the international scientific community, and they were all published in international peer review journals. So that's already, if you will, a certificate of quality, an assurance of the quality of the scientific quality of the work that has been produced. That's the first thing. The second thing is that we researchers, the most precious thing that we have associated to our name is the independency of our research work. This is our visiting card, and we take it very seriously. And when we do our research work, we do it with the objective of doing the best research work possible, independently of the source of funding for that research.